Hello guys, I welcome to you again in this wonderful video tutorial, and this would be the part 2 for the chapter that is haloalkanes and haloarenes. In our part 1 we have discussed till its density, right? We have discussed till the physical properties. Now this video basically we will deal with the preparations. What we will be doing? We will be doing preparations, right? So this video would be based on the preparation, right? So methods of the preparation of alkyl halides. So we need to prepare what? We need to prepare alkyl halides. Now what are the different ways to prepare the alkyl halides? Should we discuss this? Also, the another name for this is given by preparation of haloalkenes. Preparation of haloalkenes, right? And to study the haloalkenes is actually an important condition to study this haloalkenes and its preparation, because if you don't know how will you prepare this, then of course you will not able to use them. Okay, let's see. So here comes the methods of the preparation of alkyl halides, or preparation methods of the preparation of what? Haloalkanes. So in this method basically, let's see. So firstly you will learn from the alkanes. Second, you will learn from the haloalkenes. Third, from the alcohols. And fourth, from the by the halogen exchange method. So this would be the thing. So first is here from the haloalkenes. So remember children that from the haloalkenes, this can be prepared from the haloalkenes and haloarenes when hydrogen is replaced, when halogen atom replaces the hydrogen atom, right? For example, if I show you the example that CH4, which is methane, in the presence of sunlight and chlorine, which means what kind of mechanism it is following? Any guesses? Just tell me in the comment section. This is from the GOC. I'm again and again requesting you, just first watch the GOC videos of mine so that you came to know what kind of mechanism will be followed here, because that's the base thing. If you will not cover that, you will face the problem here. So here what happens here, methane CH4 in the presence of sunlight and chlorine, and your HCl is there. Why HCl? What is the function of HCl? If I talk about the chlorine is not selective, but talking about the bromine, Br, it is selective, because I told you na ki you have to study, basically cover the two things. One is Cl, another would be Br. Why? The reason quite simple, because iodine and fluorine are in their extreme conditions, which we are not supposed to study now, right? Because these require the extreme conditions which we cannot provide, right? So means iodine's reaction is too slow that you have to wait for a long period. Of course you may make it fast, but this is not given in your curriculum as in detail, right? Okay, so here we are in the presence of sunlight and your chlorine. My CCl means chloromethane has been formed. Now again this chlorine Cl2 is reacting, we are reacting with chlorine to whole twice, so this would give me dichloromethane. Similarly, again reacting the same thing, we will get trichloromethane, and in the end we'll get tetrachloromethane. So similarly, this is what actually thing is. Now let me just show you in the plain page, if I can show you that what this is trying to show actually. This is talking about the preparation from the haloalkanes. Talking about what are haloalkanes first of all, like CH4, CH6, these all are your haloalkanes, right? And what kind of rules they follow? Like it's having single carbon, right? It having if single carbon, then the number of hydrogens would be 2n plus 2, like n's value here is 1, so 2 into 1 plus 2, this would be 4. So 4 hydrogens are there here. Any problem here? Not that much. Hope so you are getting what I'm trying to say. Yes. So CH4, CH6 all comes under your what kind? Yes, you are saying right that this is your alkanes. Now what is any halogen group? If you want to prepare a haloalkane, means if you want to make, so for this you have from alkanes you have to make the use of chlorine in the presence of UV light, right? Or heat you may use. Let me erase it. I will just use this in next. Okay, you may use the heat. So what this will happen, this will give me, of course if my carbon was like this, like hydrogen, hydrogen, hydrogen and hydrogen, or something looks like, so of course what happened, this chlorine is already here, so this chlorine will replace one hydrogen and this will be replaced by a chlorine, by a chlorine, right? So this would be chloromethane. Similarly, if you replace two hydrogens, it become dichloromethane. If you will replace three, it will come trichloromethane. If you will replace more hydrogen, it will become tetrachloromethane, right? Hope so you are getting what I'm trying to say, childrens. So this thing is also shown you here. Also point is given that when a pure compounds are needed, they can be obtained by the fractional distillation. Are you understanding what is fractional distillation? You must have studied in your class 11, right? Now from the alkenes, in order to make the preparation from the alkenes, what you need to take care is that firstly you need to take the alkene. Of course smallest alkene is ethene, so let's take it. So here you can clearly see I had taken ethene and reacting with it with HX bond. HX, what is HX bond? Any guesses? H means hydrogen, X means any halogen, right? Any halogen. Got it? Yes. Now what? Let's see the observation. Now here Markovnikov rule will applied. What Markovnikov rule states? Wait, let me also try to show you here if possible. I hope so you have get this much. Yes, so this slide actually I had kept for making you understand the concepts and erase it whensoever is required, because everything is given here, children. If you try na, to discover that where these things are given, everything is being provided, and I will provide you the PDF of this all slides in the description box. You may check there in the end, in the last video, in the last part of this video, right? So without wasting time, let's talk about the preparation from the alkenes. From the alkenes, if you need to prepare them, firstly you need to take a alkene, right? So let's first a simple alkene, that would be what? Ethene. Yes, so I have taken this. This is my ethene having carbon double bond, right? Double bond, can you able to see the double bond? And hydrogen is attached here. Yes, now what? In the presence of HX bond, in the presence of, now giving it a HX bond plus HX bond. Now what do you think what will happen? Now according to Markovnikov rule, this double bond will break. This will break. Now if it will break, now what will happen? Let's break it. Yes, I had break it, and this hydrogen, now its valency must have increased, right? Now what will happen? The X will come to that carbon where there would be less number of hydrogens according to Markovnikov rule, right? So this X will attach to here. Basically both are same, means both the carbon having same number of hydrogens, so here Markovnikov rule is not valid. Here there will be no minor or major product will be formed. So ultimately you will get something like carbon carbon like this. Here what? Hydrogen 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 hydrogen. Here attach X, here attach one X, from here X, and here attach your hydrogen from here. Hope got it, that how the preparation from the alkenes. This is also, this was the first way, but in some cases, so from alkenes also it's clear, right? This is clear, right? Now talking about this structure, this is given according to Markovnikov rule. Some of you must not be knowing what is Markovnikov rule. So for that I have bring up the Markovnikov rule. So can you able to see here screen that the negative part of the attacking reagent itself to the carbon. Okay. So what Markovnikov rule states, again I require this in order to make you understand. For example, okay, let's do one thing. Let's try to make you understand here only. So here can you able to see that CH3 CH here double bond is there. So here Br can attach, means this double bond can broke down of course. So CH3 CH single bond CH3, this will break down to something like this. Yes or no? 1 minute. CH3, CH3, one more valency for something. CH3CH. Then of course I think here there is mistake. Here CH2 will come. Means something it looks like this. CH3CH. Here comes CH2. Right. Okay. This is somewhat it seems. Okay. Let's take the simple example. Don't make it more complex, right? Let me show you here what I'm trying to say, that if we take CH3CH double bond with CH2 plus HI, this is in accordance to Markov rule. Now what will happen? This double bond will break and here valences will come. Now where according to you this hydrogen and iodine will attach? This hydrogen will attach, means because you know that halogens are electronegative, they having partial negative charge over them. So due to which what happens basically, children, due to which this iodine will attach to that carbon where there is less number of hydrogen, and this will attach where more number of hydrogen is there. So this is actually the Markov rule. So ultimately you will get this as a measure product. You will get this as a measure product. But listen to me carefully, that if you just what it does, if you take this hydrogen and put it here and iodine here, so this would be your minor product. वह प्रोडक्ट माइनर प्रोडक्ट मेजर जो उसकी जगह में आएगा कोड जो Markov rule को follow करेगा, that would be major, and which do not follows the Markov rule, that would be minor. Hope so you got this much. Yes, come on, tell me if you have got it. Come on, put the thumbs up button right now. Now similar to this, anti-Markov rule states it's opposite to that of this, means it's the same way. उसमें चीज़ें थोड़ी उल्ट हो जाती है क्या. Let me first show you the slide of that. So hope so that you are able to see this anti-Markov rule. What it states has been observed if HBr is added to an unsymmetric double bonded in the presence of organic peroxide. Remember, this is more valid in the case of peroxide, right? Such as benzol peroxide. The reaction takes place against the Markov rule. What Markov rule said, the negative part of the molecule will attach to where there is a lesser number of hydrogens here, and this hydrogen will attach where there is more hydrogen. But however, anti-Markov rule states what it states. It states that, one minute, let's draw the neat diagram. So this was your X, HI. So according to anti-Markov rule, H will attach where there is less hydrogen and I will attach where already there is a more iodine, means where there is a more hydrogen. So this will be measure according to anti-Markov rule, but the necessary condition for this is peroxide. peroxide is the necessary condition for this. Hope so that you got all the things very crisp and clear. Yes, so similar thing is given here also. Now anti-Markovnikov rule or the peroxide effect applies. In addition, another name for the anti-Markovnikov also known as Kharash rule, right? Kharash rule. Right? Right, children? Was it clear? So similar thing is given that anti-Markovnikov rule or peroxide effect applies to the addition of HBr only, not to the addition of HI or HCl. But remember, so previously what I had done here was wrong actually, because there I was using iodine, but it was valid only for HBr particularly. Also clear? Clear? So this thing is written here. But you understand now? So from alcohol these reactions are given. From alcohols these reactions are given. Now see, the most important reaction that will come, that of course I think that would directly come to in your board examination is this very important question, that why, which method from the alcohols, or by which method you can prepare the haloalkanes best, which is the best method. So that is with the thionyl chloride. Thionyl chloride is SOCl2, and on reacting with any of the alkanes, then it will give basically why this method is preferred than other methods, because the reason is quite simple, because here the side products which are released, that is SO and HCl, these are easily escapable, because these both are gases. These are gases and these are easily escapable. Got it? Yes or no? Hope got it. Next one is by the halide exchange, or also known as halogen exchange. Halide means, what does halide means? It also means halogen exchange. Yes. So what do you think, what will happen under the halogen exchange? So basically there are two name reactions here, right? What are these? Number one is Finkelstein reaction. In the Finkelstein reaction, it is also very quite simple reaction. Here what happens, any Rx bond is reacting with NaI and giving you that Ri plus NaX. Remember what you need to remember. Also, so this was the Finkelstein reaction. Next would be a Schwarz reaction, and in the Schwarz reaction, your Rx is reacting with your Rx is reacting with any metal fluoride or metallic fluoride. Generally we use AgF or HgF2 in order to give, so here let's say MF, where M is any metal. This is giving you what? This is giving you Rf this is giving you what? Here this is not there, right? Giving you Rf plus Mx. Hope so you got up with this reaction. Like this reaction is somewhat looks like. Now most important thing that you may understand about this reaction is that देखो दो रिएक्शंस है कि फिंकरस्टीन का स्पोर्ट्स. आपने ये याद रखना है फिंकरस्टीन में आपका आयोडीन इंक्लूड होता है with sodium iodide is used here. Rx could be any, but this is unique. In the presence of acetone and heat, it will give you CH3Cl2I, means Ri. So remember, Finkelstein reaction is basically useful for what? For the production of idoethane, idomethane, or idobutane, etc. like that, in order to get the product as ido, right? So Finkelstein means ido, F for I. Next would be here Schwarz reaction, and in this Schwarz reaction you can clearly see that here fluorine is included. So fluoride, in order to obtain fluoroethane, fluoromethane, fluorobutane, etc., you will use Schwarz reaction. Remember, F is inverse because like charges repel each other. Similarly, Finkelstein does not mean for fluoride; it means for iodide. Means for iodide, not for fluoride. Got it? Yes. So hope so this both the reactions are clear, that Finkelstein reaction includes your Rx, which is reacting with NaI and further giving you the product as RXI, and also NaX, right? This Schwarz reaction basically fluorine is included and also produced. Next one is from the silver salts of the acids. So basically this reaction is not in your syllabus, but let's take it now. What's wrong with that? This is your Blorodine Hundeker's reaction. So here chloroalkanes can also be obtained by this method by using chlorine instead of bromine, but the yield of haloalkanes is very poor, so that's a drawback. So here silver acetate was there, which is reacting with Br2 in the presence of carbon tetrachloride. Now on the reaction you will get CH3, CBr, CO2, two oxygens will be separated as carbon dioxide and AgBr. So you can clearly see that bromomethane has been formed. Of course this reaction is not in your curriculum. If you don't understand, no worries, but for those who have understood, I had taken it, right? It's not in syllabus. Got it? Next would be your chemical properties. Now this is the portion which I will take up in part 3, because this is very long topic, right? Chemical properties I will take in part 3. So remember that this includes these 3 reactions. So reactions of the haloalkanes, this includes the 3 parts, and along after this, after the chemical properties, we will be discussing this stereoisomerism, and after that we will take our journey towards the haloarenes, right? Because whatsoever we are doing is generally for the haloalkanes. Similar things would be there for haloarenes, right? Like Sandmeyer's reaction means their preparation, that I will take in part 4. So hope so that you are enjoying. Just I want you to revise whatsoever is being provided to you. Understand conceptual clarity is very important, children. So meeting you in the next video. Till that, stay tuned. Have a nice day, and don't forget to like, share this video, and yes, don't forget to press that subscription button, because that would inform you whensoever I will upload the video of the part 3. Yes, so hope that preparations of the haloalkanes are very much clear. Yes, yes or no? Tell me in the comment section. Tell that bye and have a nice day. Thank you so much.